Welcome to this section on polar coordinates. We've been using the Cartesian or rectangular coordinate system to graph so far this quarter, but another useful coordinate system is the polar coordinate system, which uses distance and direction to specify the location of a point in the plane. The system is based on a point called the pole, or origin, and a ray drawn in the direction of the x-axis called the polar axis. Now I'll label the polar axis. And highlight the distance O to P, represented as r in polar coordinates. R is the distance from O to P, and theta is the angle between the polar axis and the segment OP. There is the angle theta. Theta is positive if measured in a counterclockwise direction from the polar axis, or negative if measured in a clockwise direction. If r is negative, then P is the point that is the absolute value of r units from the pole in the direction opposite that given by theta. It's opposite meaning exactly pi radians away from the positive radius. If we were to look at the first one here, we have an angle theta that looks to be about 2 pi over 3. And we'll call the radius, since it's not scaled, we'll just scale it for purposes of this video. Now the point from O to P will be the point PR theta, where r we'll call 2, and theta we'll call 2 pi over 3. Now the next one, we have an angle that is going counterclockwise from the polar axis, and it looks like it's about pi over 4. And so since it's going clockwise, I'm going to put a negative sign in front. And then I need to think about the radius here. We'll go ahead and call that radius 3 units long. So the point here will be radius of 3 and a theta of negative pi over 4, an angle. If we look at the next ray, we have an angle of pi, and we'll say radius of 2. So we can call this point P, the point, 2, comma, pi. And now I want to point out this dotted line. This is emphasizing the fact that if we are at the origin and we rotate through theta, we have gone, it looks like in this particular example, about pi over 4 in the positive counterclockwise direction. But notice that this is a dotted line. If we think of ourselves standing at the origin and looking toward the polar axis and then rotate through, so we're looking out along the angle, and then we back up, that gives us a negative radius. So the radius we'll say is 1, 2, 3, 4 units long. And it's going to have to be a negative radius because we backed up instead of moved forward from the origin. So the point here is going to be the point -4, comma, pi over 4. Here are some examples of plotting polar coordinates. The first point we're asked to plot is 2 pi over 3. So we'll start at the origin. We'll pretend we're standing there, and we will look out along the polar axis, which is 0 degrees and also 0 radians. Now we are asked to turn through an angle of 2 pi over 3, which is now this direction. And then we're asked to walk out 2 units. So the point is about here. Now let's look at example B. We're given 1, comma, negative pi over 4. So we start as if we're standing at the origin, looking out along the polar axis, and then we rotate negative pi over 4. Pi over 4 is this angle here in the negative direction. And it says to only walk out 1 unit. So I'm going to have a point right there. In these last 2 examples for plotting points, we're given in C 4, comma, 3 pi. So first we'll start out at the polar axis, pretend we're standing at the origin, and then we'll rotate 3 pi. So here's 1, 2, 3 pi. So now I'm looking out along pi as my angle. And then I need to walk out 4 units. 1, 2, 3, 4. So the point at which I am now standing is 4 units to the left, directly to the left of the polar axis. Starting point. Now let's look at the last example we have here, example D. We're given negative 3, comma, pi over 6. And so we need to go pi over 6 in the positive or counterclockwise direction from the polar axis, starting at the origin, rotating through pi over 6. So I'm still standing at the origin, but I am going to just put a dotted line here at pi over 6 and then back up 3 units. So that would be along 7 pi over 6. And now I just need to figure out where that will be. So notice that I've taken pi over 6 and added pi to it, which will be equivalent to backing up 3 units. 1, 2, 3. There's my point at which I'm now should be standing. And that pretty much does it. If you think about standing at the origin, rotating through an angle, and then either walking forward or backing up, you should be able to plot all these coordinate points very quickly.